Hello guys, welcome back to the channel. So today we are seeing my DMW project on which we have worked as a team with my members as Bhavna, Sharvin, Mayur and me myself Abhishek over. So here we have done stock market data analysis for our DMW project where we have compared LSTM, AR and Arima model. So yeah, this is our report of mini project. Here these are the libraries. I will explain you in brief in further video. So this is AR model. So AR model is our first model. So here you can see this is okay. It's not highlightable. So yes, you can see my mouse. So here this is the formula on which the AR model works. So what AR model exactly does is, suppose there is a graph. I think there is one. Okay, here it is. So suppose these peak points are those graph points where the data is present or data about that point is present. And what AR model does is AR model uses every previous data, like even if the first data is valuable in that formula, if you do that recursively you will reach and understand what I am talking about. So if you do that you will realize that even data of the first reading is also used to predict the future readings. So the issue with it is it doesn't I can say it is not very good for data which keeps on changing for a short term or for short time. So okay, so this is the formula for AR model. This is the mathematical representation, I can say. So next model is Arima model. So Arima model is basically a mixture of AR model and moving average model. So let me just explain what moving average does. So just like we talked, like these peak points are the different or the recorded points. So what it does is the AR it keeps on, it just predicts the some value based on some previous values, and it calculates the difference between the real data and the predicted data, and on that basis on the basis of the difference it keeps on readjusting itself. And what it does is it just keeps on considering difference for a small amount of data and adjust accordingly. So in Arima model what we do is we kind of mix both of them. We mix AR model and moving average model. So here we also use every point for prediction in our next point, and also we record the difference, which is the difference which is between our model's prediction and which is and between the real reading. So in that way the Arima model predicts its data. Yeah, this is the mathematical representation of it. And the third one is long short term memory model. It is basically RNN model. I don't have much explanation on this. So these are the source codes. So here you can see we have imported libraries. Here we have used stats model library because it is well-known library for I can say seasonal datas like stock data or any kind of seasonal data. And here all these model are basically just like we can say prediction models. So they predict, or they I can say a regressive, or they are actually regressive models. So when we work with machine learning, so we kind of judge them basically on the errors. So here we have used mean square error. There are three kind of errors in which we have considered in this project. So here this is just reading the whole data. Here this is fitting up of whole model similar, and these are the I can say, here you can see this is the close price, this is the test close price. If I don't know you can see this or not. Okay, so here it is. So the green line is actual price, the blue line is the predicted price, and the red red line is basically the test data for which the model has been tested. So yeah, this is the data on which model is tested. This is the red is the real data and blue is the predicted data. So let me just zoom it back. Okay. Similarly, the code is for Arima model. Here you can see it, and here there is for LSTM model. So now if we do the comparison between them using mean square error, mean average error, and root mean square RMSE error, so here you can see the mean square error for LSTM is very high, and in compared with Arima model, in Arima model, AR model have more errors. So in that case we can say Arima model is much better performing for, I can say, the stock market data. So let me just tell you where we took data from. So this is the stock market data. This is, I will mention the link in description. So this is the data which has recorded the values of each company, and I mean the stock values have been recorded over a period of time. And we have just done for Goldman Sachs company's data. So yeah, this is the real working code. So here we can see the models have been imported. Here the errors which or the matrices on which we will judge the model is been imported. Here only the data is imported, Goldman Sachs US data. Here you can see the data is in CSV format. So here we are just visualizing our training data. This is the whole training data. Here this is the demonstration of our code. Here we have just split that data. Here the green data is training and blue data is test data. Here this is code for AR model. So here you can see the whole model gets tested here itself, and here we have plotted the difference or the original values and what the values were, and the both RMSE, ME and MSE errors have been printed here. Similarly for Arima model, here the model has been tested. Yeah, this is, I can say this is the seasonality of the data. We have just checked the seasonality of the data what it is, and we have just showed in format of a graph which is plotted using matplotlib. Here this is Arima model being trained. And here the errors are getting printed. Here this is the graph for it. And now this is a little bit of pre-processing done for our LSTM model. So here you can see the pre-processing or whatever the requirements are have been done now. And here we have started building our LSTM model. Yeah, the model has been trained, and these are just some sample visualizations. So these are the visualizations for LSTM. So yeah, this is the whole, I can say, code.